All right, hi, welcome. Welcome to day 8 of my Advent of Code stream. We got transitioned here over to the my screen here. Yesterday we finished Advent of Code quickly enough that we were able to start working on the roguelike that we put on hold for a little while. But let's see what day 8 has to bring to us. So let's go over to our Advent of Code. I did day 7 yesterday because it was day 7, but I did day 7 yesterday in a way that I wasn't all that thrilled with after the fact, right? So I looked at day 7. That's just the test input. I noticed, I thought about it a little bit, and I noticed that this could be actually cleaned up a lot. I was thinking about how to do it in a Rust-like way. But let's work on day 8 first, and then if there's time, because I don't know how tough day 8's going to be. So this is getting nice and long. It's going to get 25 long pretty soon. Day 08, day 08. And this should fail. Good. And then if we make dir source day 08, and then edit source day 08 mod.rs, and we'll create a quick runner here, day 08, just to make sure everything is up and running. That checks, and it runs. I gotta change this so I can just run the current day if I want. We'll see if there's time. All right, so we're ready for day 8. Who's ready for this? Not me. Day 8. Oh boy, wall o text. Oh, this looks tough. Okay. 7 segment search. You barely reach the safety of the cave. Oh, that's right. We blasted through into a cave using the crab submarine help. When the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them. Do we know what they mean? So you'd better figure out what's wrong. Each digit of the segment display is rendered by turning on or off any of 7 segments named A through G. All right, that makes sense. So to render a 1, C and F are on, and the rest would be off. Render a 7, A, C, and F, and so on. Okay. The problem is that the signals which control the segments have been mixed up on each display. I'm trying to think of what kind of an impact on our submarine would mix wires up. Right? Let me pop my chat out so that I have a little window for it. There we go. Okay. Sorry. All right. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each digit, each 4-digit display. Okay. All the digits within a display use the same connections. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. Only the digit that uses 2 segments is 1, so it must mean that segments C and F are meant to be on. With just that information, you still can't tell which wire, B or G, goes to which segment, C or F. For that, you'll need to collect more information. All right. For each display, you watch the changing signals for a while and make a note of all 10 unique signal patterns you see, and then write down a single 4-digit output value, your puzzle input. Okay, is that the single 4-digit separated by the thing here? Okay, so this first part, each entry consists of unique signal patterns, right? A pipe delimiter, and finally 4-digit output value. Within an entry, the same wire segment connections are used. Okay, unique signal patterns correspond to 10 different ways the submarine tries to render a digit. All right, I think I get it. Using this information, you should be able to work out which combination of signal wires, oh boy, then you can decode. Wow, okay. Unfortunately, in the above example, all of the digits in the output value use 5 segments and are more difficult to deduce. For now, focus on easy digits. Consider this example. I see that these are highlighted. 7 and the 4. Okay. Because digits 1, 4, 7, and 8 each use a unique number of segments, you should be able to tell which combinations of signals correspond to those digits. Counting only digits in the output values, there are 26 instances of digits that use a unique number of segments. In the output value, how many of those appear? All right, so let's start by, and we're going to eventually have to decode the whole thing, I'm guessing. Because they were talking about doing that. We're going to focus on the easy digits for part 1 and then decode everything for part 2. So let's grab, what was that that function I was using? 04, right? Day 04 we had to read, yeah, read file. So let's grab those lines and put them here, and we're going to just say day 8, right? But I want to do test input first. So in, let's see, source inputs, let's say test input day 8 is that, and this is all on one line, right? Let's just double check our test input is actually that. Wow, yes, okay. Just out of curiosity, how many lines are there? 200 lines. Okay. And we will save that in input day 08. Oops, day 08.text. All right, so we have the test input, and we're going to read that here. Okay, so that's all cleaned up. So this is our test data. So we'll call this test input. And then what are we going to do? We're going to split for each line. We're going to split on a pipe character. Right? For ln lines, why don't we just pass it into a function? We'll say function count for part 1, which takes a line, which is a string, and returns an I32, and it tells us how many 1s, 4s, 7s, or 8s in a given line. And then that way we can just loop over them. So what are we going to call the second half? The code is equal to line.split on a pipe character, right? And we're going to get the second one and unwrap it. And let's just print that out just to make sure that's what we're seeing. Anyway, we can run count part 1 for each line, right? And it didn't work. Oh, because I didn't return a 0 here. Lines has type vex string. Oh, duh. There we go. Okay, so that checks. And are we getting that? Yeah, it looks like we're getting all of that. The second half of the code. So that's one step in the right direction. So now we need to split by white space, right? Let digits, I guess. And we're going to split on white space, so we can tell it we need a vec of strings is equal to code.split white space. And then can we just say collect there like that? Because we should have an iterator. Nope. The trait from iterator is not implemented for vex string. Huh. Okay. So this saying value of type vex string can't be built from standard iterator item stir. ToString collect? No, it doesn't like that. Maybe we just have to map x.ToString. I'm just stabbing in the dark here. Okay. And then we'll just print out the digits as an array. See if we're getting that correct. Yep, so we've successfully split everything, and now we want to, for each one, we want to loop over the digits for D in digits. And we want to say match D.len, right? Because 1, 4, 7, or 8, but it's not 1, 4, 7, or 8, it's 2 for the 1 digit, 4 for the 4 digit, 7 gets 3, and 8 gets all 7 segments, right? So let mute total 0, total plus equals, and it'll be count up to 1 for that, and anything else gets 0, right? And then we should just be able to print out total here and return total, right? Let's try running that. I'm going really fast here because I'm worried about day 1 is going to be annoying. Or sorry, day 1. Part 2 is going to be annoying. How did I come up with day 1? All right, so we got each one of the counts. Now all we need to do is sum them up. For some, actually we can do this in a rusty way, right? We can say lines dot iter dot fold 0, the sum, and the next line, right? It's going to be count sum plus count part 1 of the line, right? Dot sum, right? And that'll be day 08 part 1 is just this. That's a rusty way to do it, right? Does it even work? No. Method cannot be called on. Oh, I'm already summing them up here. Duh. That's a rustier way to do it. There we go. Okay, so if we run this, do we get 26? Yes, we get 26. Okay, so that's working. Let's get rid of this println and change this to our real input. I did not copy it over. Okay, so move downloads input day 08 to inputs. Okay, let's try that again. 409. All right, that's the right answer. Okay, that's good. But I bet the next one's going to be a little tougher. Through a little deduction, you should now be able to determine the remaining digits, of course. Consider again the first example above. Blah, 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 blah. After some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration. So, the unique signal patterns would correspond to the following digits. Then the 4 digits would be 5353. Following the same process for each entry on the second larger example, we decode all those. So easy. So easy. This is einfach, as they would say in Germany. Okay. Let's see if we can, we'll switch back to our test input because I want to see, it looks like we're adding up all the numbers to get 61,229. But how the heck do we do this? How the heck do we do this? All right. So we know we can compare 1 and 7, right? We know which one is 1 and which one is 7 based on the length of the of letters, right? We know this is a 1 and and this is a 7. So we can compare the two and say, okay, BE is 1, although we can't tell if the top one is B or E and the bottom one is B or E, right? And this is 7, but because D is the only new letter in there, we know that D is the top segment, right? Because that's the only one that would show, oops, that would show up here, right? This would be B or E. Each one of these would be B or E, and then the top one has to be the D. But how do we make that into code? And that's just giving us 1. All right, well, why don't we, oh, whoa, I meant to scroll here. Why don't we write down in a little comment here at the top how these numbers compare. We have digit, and we have number of segments on, right? So this is for digit 0, we have 6. For 1, we have 2. 2, we have 5, looks like. 3 is also 5. 4 is 4. 5 is 5. 6 is 6. 7 is 3. 8 is 7. And 9 is 6. All right, is there any other information we can glean from this? What we can do, looking at this now, what we can do is we can count how many segments are on, right? Because we have all 10 digits here, right? And certain segments are going to be on a specific number of times, so we can actually count how many times those are on. So let's do a new table here, and we'll do a segment and a count for that segment, right? So for segment A, it's on 1, 2, 3, 4, 5, 6, 7, 8 times. B is on 2 and 4, so 6 times, right? C is on 5, 6, 7, 8. Uh-oh. If these are all going to be the same here, that's going to be annoying. We got 3 here and 4 here. That's 7. Okay. Maybe this is going to be promising. Maybe this will work. We have 2 E's here and 2 E's here, so that's 4. For segment F, we have 4 and 5. That's 9. Okay. This is good. This is good. I think this is going to help us here. And then G's looks like 7. All right. So D and G we can't distinguish between, right? And C and A we can't distinguish between. But we can tell which segments are B, E, and F. All right. So we can get A based on the difference between the 2 and the 3. We can get B, E, and F based on the segment counts. How to model this though in code, right? How do we say, okay, well, we have a 3 and a 2. This first part is not helping at all, right? All this is doing is saying, can you parse the input, right? If you can parse the input, you can answer this question. And parsing the input is not the hard part here. So what can we do? Can we create a function which will return what? Which segments map to which letters? Right? Do we want like a map, like a hash map that goes, you know, A maps to D and B maps to F and so on? How can we go from this to generating a decoder for the main digit here? Because these are all scrambled. We can sort them, right? We can sort these, and then maybe once we have a decoder like this, we can generate, you know, for 0, it'll be whatever letters go into those segments. That's going to be a lot of work. All right, so let's see if we can write a decode that decodes 1 and generates a hash map. Right, so we'll give it a string, just like we did for count part 1, and it'll return a hash map. of char to char, just like here. We'll need to grab standard collections hash map. All right, and now we want to split on the first, right? Let values equals line dot split on pipe. Next, unwrap. And let's just print that out. Make sure we get the right thing here with our test data values. Print. And we're just going to call decode 1 on lines of 0. Doesn't like that. Unexpected token. Oh, duh. And we need an ampersand. And, oh, hash map new. Okay. All right. Let's run that. Okay, so we did split that up there. Okay, that's step 1. Step 2 is to split it with the white space. Like we did here. And we'll call it digits again. It's killing me. Okay. And so we'll print out the digits. And we have to change this to values. That checks. And then it's just the same exact thing where we get an array. And now what we're going to do is we're going to look for the segments that have 2 and 3. And subtract, right? This from this. Oh, how do we do that? This would be so much easier in Python. Okay. If we loop over each one and create a vector of hash sets, right? For D in digits. So let's say, I don't know what a hash set, I guess. Hash set list is a vector of hash set of char equals vec new. And then we're going to say let hash set is equal to hash set char, no, new hash set char. Okay, I'm trying something here. So for D in digits, so now we're going to loop over each of the characters. For C in D.chars, set dot, is it insert? Rust hash set insert. Is it just, I'm just trying to see if it's just, yeah, just insert. Okay. Insert C. Right, and then we'll just say h set list push hs, right, and that should build us up this h set list. Let's run that. Oh, we can't do that because it's not mutable. All right, so we have now a vector of hash sets. So now, how can we do this? We want to say, we want to grab the one that has a length of 2 and one that has a length of 3. There's got to be like a programmatic way to do this, like through process of elimination. We should just be able to say, okay, this is length 2, so the possible segments it could be are these. And then we loop over those and say the possible segments are, you know, what segments are remaining and remove those, what segments are remaining and remove those, and so forth until we get just a map that goes from char to char. I don't think I could do that on the fly though, so I'm going to do the brute force method. Hi Knock, how are you? Welcome back to the stream. So I need to just loop over each one of these sets and see what the size is, right? We can get a size on the set, or len. There's a len, a number of elements in the set, okay. So I'm going to say let mute is 1 and let mute is 7. We're just trying this out here. If hs.len equals 2, then is 1 equals hs. Else if hs.len equals 3, then is 7 equals hs. And now we should have both of those guys, right? Come on. 1 is this guy, and then 7 equals this guy. Is 1 is 7. Oh. Yeah, okay, maybe this just needs to be a reference to that hash set. No, it still doesn't like it. Move occurs because that barred value does not live long enough. Oh, I have to get it from the hash set list. Actually, so if I just put this here, then it should work. Oh no, because we're going to do through each digit now. All I want to do is take a look at which one is length 2 and which one is length. So we're going to say index and digit, and we're going to enumerate on those. And so we're going to just save I here. And then we can say on the vector, hset list of is 1 and hset list of is 7. That almost checks. Oh. We can't enumerate on a... Stop doing that. Oh, let's do that here. Maybe that's what's complaining. And it is 1. Oh, possibly uninitialized. Okay. So let's just set those to 0. Think we might be there. We're there. All right. So 1 is B and E and 7 is DB and E. Okay. So that gives us that. Which means that segment segment A is equal to hset list of is 7, hset list of is 1. I don't know if Rust allows you to do that. It does not. You can't subtract hash sets. So how do you do intersection on hash sets? Intersection. Does that intersect it and change it? Or does it create a new... Oh, so it creates a new one. Okay. So we can do that. Hset list 7 intersection with that guy. Collect. And then we can say println segment A is equal to that. Whoops. Okay. Oh, I need to give it a type. It's got to be a hash set. They just put an underscore. Let's see if I can do that. I can. All right. So run. Segment A is E and B. Oh, no, I don't want intersection. I want the difference. I want the difference. Right. Intersection, change that to difference. right? D. Yeah, okay, so we know now that segment A is D. So we got one segment out of it. So the next thing we need to do is use this knowledge that we had from before, right? Of counting, we can get B and E and F just by counting the number of times a letter appears, right? So for that, we can create a vector. Vec of I32, I guess. Just say the vec is vec bang of I32, and there's only 7 different segments, so we'll do that, and then we'll say D in chars. We'll insert C, but then we'll say counts of C as usize minus A as usize plus equals 1. And then we can take a look at the counts down here. Counts. No, it doesn't like that. Oh, it has to be mutable. I keep doing that. Okay, let's run that. And it panicked. Len is 2, but index is 4. Really? On line 37. Len is 2. Oh, that's a semicolon. There we go. Okay. There. Okay, so we got 4, 8, 7, 8, 9, 7, 6. And those should map to here. We have a 4, 8, 9, 8. Oh, sorry. 4, 8, 7, 8, 9, 7, and 6. All right, so we know that based on that information, we can search the counts array and figure out what the 3 other segments are. So we set seg A here. We can say let seg. We know it. Let's close this window. Pull this chart up. We can make this smaller, right? One more? Nope. Okay. Where was I going? Here. So let seg B, and we're doing a hash set here, but we can pull the char out of it, right? Char equals question mark, and so we can get B, E, and F. Right, and then say for C in counts, if C is equal to 6, then seg B is equal to A. No, seg B is equal to, oh, we need to do the enumerate again, because we need to know the index to get the right character. So it's A as usize minus 1, no, plus I as char. So if C is 6 or C is equal to 4 or 9. Oh, no, we can't do it that way, because we have to do each one individually. Else, if C is equal to 4, we should probably be doing a match, right? 4 is E, C is 9, and then we just seg F. So then we can print those guys out. Seg B, seg E, and seg F. Seg B, seg E, and seg F. Oof. Okay. And that doesn't work. We can't do that. We have to throw in an extra iter. Nope. We have to star these guys. And we can't do that. Invalid cast. Only U8 can be cast as char. Okay. Okay. Okay, so now we're mapping to letters here, right? So G, A, and E are our other segments. So we've got 4 out of the 7 segments done. Now, how else can we deduce? We know that segment A is D. Does that help us with, no, 2, 3, 5, and 6 are all. So we have A, B, E, and F. So what we need is segment C, which is this guy here, and is there anything we can do to distinguish between A and C? Well, we know A, right? So C is going to be the only other one with 8, right? Yeah, they're both 8s. So if we know segment A, then we can get segment C based on it's the only other one with 8. So we can say else if C is 8, then we have to say, are we on segment A? So, which would be I equals 0, right? And I is not 0. Then we can do seg C is equal to this mess. Right? So let's add that. To our list of segments here that we're slowly building up. Seg C is that. That does not check. Why not? Did I mess up a close? Yeah, I did. There. Okay. Does that give us segment C? No, it doesn't. It came up the wrong one. It came up with D, which is segment A. Oh. Wait a minute. So what we're pushing in here is the actual letter. And then we're decoding it here using this and using I to determine what letter it should be. So is this backwards? Am I doing this backwards? Because I say segment B is G. Let's take a look. How many G's are there in this thing? We have 1, 2, 3, 4, 5 G's. Really? 1, 2, 3, 4, 5. Oh, 6. 6 G's. Yeah. So that means segment B is G. Yeah. Okay, so what am I doing wrong here? With segment C, this is showing D, but we want to say I is not equal to 0. Let me print out the counts array again, because I'm obviously confused about something. There we go. Yeah, so if C is 8, we're hitting this. Oh, it's not, I is not equal to 0. we don't know which one of these is, like this is A, B, C, D, right? And we know that A is D. Okay, so we just have to compare it. If it's 8, then we're going to not try, we're going to say let temp is equal to that, and then we're going to have to actually set segment A in a better way here. How do we get the entry out of this hash set? That's the one thing I didn't get. What does get do? We pass in the value. Return the value of the set if any is equal to a given value. So that doesn't help. I just want to get the, oh, we can iterate. No, we can't. Can we iterate? There should only be one entry in the thing. Can I say iter next unwrap? Because I want to compare it against the actual value, right? Seg A is D. Yes. Okay. So now instead of having that set, I actually have the actual character. All right. So can I just say iter next unwrap here? It's a little sloppy, but it might do the trick. No, it doesn't like that. Oh, type annotations needed on collect. All right, so let's just do it this way and call this segment A hash, and segment A equals segment A hash. Oh, I know why it messed up last time, because I did it this way. All right, I'm not going to clean it up now. I'm too lazy. Okay, so this is this, and then we just want to say if C is 8, let temp equal that, and if temp is not equal to seg A, then seg C is equal to temp. Wow, this is messy code. That does not check. Oh, is this a reference to a reference? I'm just going to do one for now and see what that turns into. Yeah, see, that does that. But I definitely want to just have it be a single character. Wow. Who knew? Double D reference. Okay, so does that give us the right value for... Yes. So because segment A has 8 appearances and it's D, therefore segment C must be B. So we've got A, B, C. We just need D and G. So one of them we should be able to figure out, and the other one we should be able to just use process of elimination. It's the only one that's left. So D, what can we say about D? So D is in 4, but not 1. Right? And 4 is one of the unique ones. Right, so else if hs.len is equal to 4 is 4 equals I. Right? Wow. I hate everything about this code. Maybe I'll figure out a better process of elimination thing later. All right, so, and then we can use the same set logic here. If we subtract the hash set 4 from hash set 1, we'll get B and D, right? And then subtract B, which we already know, right? So we'll just do these 3 lines again. and seg d hash. This is 4 and difference of 1. Let's see what does that come up with. Oh, we won't be able to do the next unwrap thing here. We're just going to have to do seg d hash for now. Boy, oh boy, that's getting annoying. Okay. Does that check? It does. Let's see what seg d hash looks like. Seg b, sorry. So G and C. All right, so then after we figure out seg b, oh, and this is not seg b, this is seg d. Why did I do that? Okay. So once we figure out seg b, then we should be able to figure out seg d by doing a remove. Seg d hash remove seg b. This has to be mutable then. And then seg d right? Seg d is equal to seg d hash. Same thing we did before, iter next unwrap. And then bc seg d is equal to this. Let's put that on another line. That does not check. Expected reference found char. Okay. So that's easy enough to fix. Run that. All right. So A is D. Why is that coming in quotes? I'm worried now. I don't have it right. Oh, because I printed debug. Okay. So seg A is equal to this. Seg A. So we have A, B, C, D, E, F. We just need G. And G is the only one that's left. It also has a 7. So it's either going to be this guy or this guy. And what we can do is, oh, seg D gets set here. And once we know seg D, then we have to loop again. I don't want to loop again because we need to find out if we're hitting, if we hit a 7 and then remove D from the 7. And I don't want to do that, loop that again. So else if C is 7, wow, this is going to need a lot of cleanup. Let mod 7s back y32 back new. Oh, no, we want to insert the character that it could be, right? Let's make it a hash set because then I can just subtract. Char. Those hash set new. Right? And if it's a 7, we'll just say 7s insert this mess. Oh, come on. Y here, there, like that. And then at the end, we'll say 7s dot remove seg D, and then let seg G is equal to 7s dot iter dot next dot unwrap. right? And then we can put that here. Seg G is equal to that. Seg G. It checks. And it comes up with F. Okay, so they don't, do they say for the first one what each one is? All right, so seg A is D, seg B is, wait, how do they, oh no, I got these all, oh man. I'm assuming this is the one with the first test input here. Did I switch back to my test input? I did. Okay, the first example above. Wait, that's not the first example above. Oh, the first example. Okay. This example. All right, this is the one they're doing here. All right, so maybe it's not broken yet. Let's find out. We should be able to just decode that directly, right? Oh. Decode one of this to string. Or maybe we don't even need to do that. Right? Okay. Okay, now let's compare. So, segment A is D, segment B is E, segment C is A, segment D is F, segment E is G, segment F is B, and segment G is C. Okay, so we've decoded successfully. Now we need to figure out the signal pattern, right? Because these are all scrambled. Is there a way to compare hash sets equal to each other? I guess if the intersection is equal to the same thing. Symmetric difference. I don't know what that means. Remove, replace, reserve, iter. Can you compare hash sets? I say, are they the same set? Is disjoint? Is subset? Is superset? If it's a subset and a superset, then it would work. But I don't have to do that. Bit and. Shows the intersection of self and right hand side as a new hash set. Okay. Rust. Hash set equality. Rogue Particle says this is a mind-boggling problem. Yeah. Hi, Rogue. By the way, thanks for joining. It is going painfully slowly for me. Yes. I have 200 lists. I want to do hash set equality. Come on, EQU EQUAL. Now that's the only place where the word equal is. Must program to compare hash sets to using equal operator. Iter clone collect, iter clone collect. Oh, you can just use the equal sign? This is not really a okay. I'm going to see if that's true. Okay, so we know that 1 is a hash set containing B and A. So let's see if I can say let check. Let me turn this off. It's blinding. There we go. There's a hash set of char. Hash set new. There's probably an easier way to do this. And then check insert A, check dot insert B, and then if we're going to say println are equal, And we're going to say check is equal to hset list is 1. Does that check? It does. Does it run? Oops, I got a double run window now. They are equal. Okay. So that's going to simplify things. We don't actually need to like sort these and make sure that the strings are equal. We just need to check that the hash sets are equal. So what we can do is build up a hash set now of each of the segments and return that. Right? So instead of returning a hash map, what we'll return is a vector of hash sets, and each entry in the vector will correspond to the digit. Is that crazy or what? And then how do we insert like a list? Insert from vector, because we should be able to do that, right? From iter. Okay. All right, we'll figure it out. So this is going to be a vec of hash set of char. All right, and then now down here, we're going to generate for each digit type what digits. Like for example, O is going to have A, B, C, E, F, and G, right? For 0. So let 0. Can I do this? Seg A, seg B, seg C, seg E, seg F, seg G, iter, collect into a hash set. Rust hash set from iter. Yeah. Hash set from iter. Okay. Oops. Hash set from iter. And this is a vec. I don't know if I have to specify that. And we're just going to print this guy out here. And see if that's what we're expecting. And if I hit F1 one more time in the stream, what did I mess up here? Seg G. Expected char found char. Oh, okay. I gotta put a star in front of it. Okay. That's an easy fix. Okay. We're iterating over the chars, but we're getting char references, I guess. How do we dereference it? We just do this. Is that cheating? Oh, and I'm not returning the vector yet. Okay, let's return the vector. So that actually worked. Vec new. We have 2 warnings, but let's run it and see if 0 is the hash set that we're expecting. Is 0 is G, right? C, D, E, A, and B. Perfect. All right, and so now we can actually just check to see on the first part of the string to see what digits they are. Right? But we have to do one of these for every number. And this is going to be painful, right? There's 10 of them. Okay, so just get cracking. There is an easy way to do this, but I'm just going to brute force it. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And this is going to be easy to make mistakes, right? 7, 8, and 9. Okay, so 1 just needs segment C and F, right? 2 is A, C, D, E, and G. Three is A, C, D, F, and G, like that. A, C, D, F, G. 4 is B, C, come on, here we go, D, and F. And then 5 is A, B, D, F, and G. 6 is A, B, D, E, F, and G, right? 7 is A, C, and F. And then 8 is all of them. A, B, C, seg D, E, F, and G. And then 9 is all but, you know what I should have done was started with 8 and just deleted the ones that weren't there, right? A, B, C, D, F, and G. All right, so the vector of we're going to create, can we do from? I don't know. Vec, bang. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Does that check? We have 2 warnings. Let's just check the warnings real quick. Oh, I'm sorry, I'm missing the chat here because I'm absorbed in my thing. I got to delete this guy. How do I block him? There we go. Is buying fake followers and viewers really popular when you... Yeah, General Nova, I bet it is a bot. And I think it's just, you know, they create accounts that they scam people out of money, and then that's the end of that. I don't know who falls for that though, right? I mean, people must be falling for it. I'm not using hash map now. Oh, I guess I'm doing just hash sets. All right. So I think we're really close. I think we're really close. We have the array. This checks. We can run it on test input now. The decode will tell us, well, we figured out the digits, and now actually we should be able to just in decode get the second half of this thing. Wow, this is a long function. This is painful to look at. So what I should do is just say let split is equal to line dot split of this, and then we'll just say split. Oh, it's got to be mutable because we're going to be split. We're going to be doing a next on the iterator. Split next on wrap. This should still check, and it does. And now at the bottom of this, let decoder ring is equal to that. And we're going to change the return value just to be the I32 of the sum. The I32 of the sum of all of the values here, or the digits, sorry. We're going to have to convert these into individual digits and then create a 4-digit number out of them. Okay, we can do that. So this is our decoder ring. I'm just going to put 0 here to make sure that everything still checks. This warning is probably because I'm not using decoder ring yet. Okay, so what we're going to do now is get the next split. Let digits, I probably already used digits. Let number segments, I did not use segments, okay, is equal to split next. What was it? Split next something? Unwrap. My brain's going. I couldn't remember unwrap. Okay, so now those have to be split into white spaces, right? Actually, we can just say for D, let mute result equals 0. For D in segments split white space. Can I do this? I'm just going to print these out just to see D. Because we have to convert these into hashes. Oh, did I misspell it? Split? Oh, yes, split white space. There we go. Okay, so that works. And if I run that, it does print out the four segment digit display things. Okay, and we should be able to get out of this, we should be able to get 5353, right? So the first thing we're going to do is we're going to say result times equals 10. So we don't want to forget to shift that up. Then we're going to say, we're going to split the D into a hash set. Sorry, I can't read your name. Mummy Jamala. Okay, Mummy Jamala, is there a way to abuse macros to get rid of all this hash set from it? Oh, yes. Yes, there is. But if you're pressed for time, as I am, I have maybe another half hour left to go. I don't have time to do proper software engineering. I mean, this is all terrible code. I admit that right up front. This is all terrible and can be cleaned up massively. And I actually haven't done macros on stream before, so maybe that's something that would be good as a learning thing. I could go through and figure out how macros all work. But that's not today. Let's see. So we're gonna split D by its individual chars, right? And then we're going to create a hash set. We did it from iter before, right? Can we do that? And then just print that out. Will that work? Epic says we should call it brute force rather than terrible. Yes, okay. I am brute forcing my way through this awesome problem. Hi, Sam. You can do hash set from food directly. Oh, you can? Just like that? Brute force would be trying every permutation. This is not brutish at all. Okay, thank you. I appreciate your support. That makes it, that helps. Okay, that didn't work as from array. Yeah, but cannot infer type. It didn't like that for some reason, just saying from. I had to do from iter. And that worked. Maybe there's some other thing in there. Okay, and now we get the hash set CDFEB, CDFEB. All right. And now we just loop until we find for code in decoder ring. If HS is equal to code. Oh, dang it. Got to do this too. If HS is equal to code, then result plus equals I. And then we return results. Is that all we have to do? From seg A, seg B. Oh, up here you mean. Okay. Yeah, let's try that. Let's save five bytes there. Right? Oh, because I'm doing this iter map thing here. Yeah. All right. So that's much better. Thank you, Sam. I will clean that up as soon as I figure out what I did wrong here. Oh, I have to do turn it into an iterator like that. And then return result, expected I32, but result is of type usize. Of course it is. Why not? Make that a usize. Okay, that checks. Did we get 5353? Oh, I didn't print it out. Println. $53.53. Wow. Holy crap. Works for hash maps 2 with tuples. Okay. I took all my hash maps out, but yeah. So let's clean these up. We can change all the from headers to from. It's a little cleaner this way, right? And then we can get rid of all these iters here. Iter like that, and just change it to that. And then see, this should still generate 5353. And it does. All right. And then we should be able to use our test input to verify 61229. We just have to loop over all of them. Right? And we can do the same thing here, right? With this lines iter fold thing. Day 08 part 2 is this, and instead of that we're going to say lines iter fold 0 sum line sum plus decode 1. I'm going to change the name of this thing in a second. Get rid of that, do that, and we're still using our test input to see if we get 60. Oh, we did. Holy crap, this worked. I am in shock. All right, let me get rid of my printlns because that's going to get very noisy for the real input. Right, okay, let's check that. Do another run. All right, and now we use the real input and pray. And we got a number. It didn't crash or panic or anything like that. And that's the right answer. Awesome. All right. Thank you, everybody who joined me here on the stream for helping out. Sam, Epic. We're going to ignore the spammer. All right. This is awesome. Okay. So oh, you know what I forgot to do is check in part 1. So we just have part 2 as our thing. Let's see what Clippy says about this code. Clippy doesn't mind our interesting approach to the code, so we'll just go with that. Git status, git add dot, git commit, gem, day 8, parts 1 and 2. All right, let's push that up. I thought that was going to take a lot longer than it did, mostly because I was struggling at the beginning there trying to figure out how to approach this problem, figuring out how many segments are in each digit, and then figuring out this was what I think was key to solving the problem, and then doing a little process of elimination. I think what would be easier would be to just take a number. We can take a look at the inputs. To take each one of these and say, this is possibly, because we know this is a 1, this is possibly which segments. And then slowly, and for each one of these, we just add those to a possibility matrix. And then just loop over it many times using process of elimination, saying which one it could be. General Nova says, yay, yay, thank you, General Nova. Epic says, I would probably have tried to solve it using bit masks. Yeah, that would have been a very smart approach. It probably would have been, yeah. And now that you said that, I'm going to be thinking about that all day, and maybe I'll hack on it off stream and see if I can come up with a good bit mask approach. The only key is storing it as a 0 or 1. We still need a way to say we're not sure if it's a 0 or 1. But let me think about that. That would be an interesting approach. But your version was much better for learning Rust. LOL. Yes, I did learn a little bit about this double. I got a double indirect up here in order to get the data out of the hash set, which I was surprised by because this one only needed 1 star. This one needed 2. So we learned a few things here and there. Now that this is checked in, I'm going to go back to yesterday, because yesterday's code also bugged me. I think that this can be cleaned up a bit. And I also wanted to try, we've got this callback function, and what I'm doing is I'm passing in pointers to functions which just do these little things. So just to recall, day 7, we were lining up crabs to try to do a minimal fuel costs for part 1, which is a linear thing, and then I call this arithmetic, but it's actually exponential. It's dist times dist essentially. But what I wanted to try to do was figure out how to do this with closures, because we should just be able to say, say cost crabs of I, and then just pass in a closure saying that for the first one, and x times x plus 1 over 2 for the second one. Right? I think we can do that. Let me extract first this code here, right? And put it in here as so I can loop over it. Oops. Like this. Oh my God. Like that. Okay. So, guess we can call it total, and we get the crabs as a hash map. And we're going to have to pass in largest. And we're going to pass in this callback function, CB. Right, and that gets passed in here like that. I think that's the way we can do it. And then we should be able to say total here, right? And then we have to return the total. So this needs to be here. And we'll return it here, like that. Like that, right? So we can say println day 07 part 1 is this. So this is a little bit cleaner, right? And then day 07 part 2 is going to be equal to this. And then we don't need these guys, right? Does that check? It does not. Oh, yeah, we have to pass in the largest. It still doesn't like it. FB. Oh, just F. It's FN, like that. And this cannot be formatted. Really? Oh, because I'm not returning an I32. All right, that checks. Mummy says, I solved it pretty much the same way you did, except I just used sorted strings instead of sets. Yeah, they both would work, right? Sorting the strings and then just comparing them. I figured I had the sets already. Ooh, I just ran this without even knowing it. Oh, wait. Oh, yeah. Okay. So just double checking here. 30 347, 449, and that. Okay, so this still works, and I used a closure instead of a function pointer. But I want to take this one step further, because I think we can just loop over these guys here, right? We can just say Krebs iter. We can iterate over them and then just call cost on each one. Map for each crab, we'll say get the cost of, oh wait, no. For each I. Okay, not crabs iter. Then we want to say 0 dot dot largest iter. We're going to pass in the crabs. We're going to pass in X and our callback. And then we can just say min on that. Will this work? It does not check. You can't iterate on a range. You just do that then. And we get rid of the semicolon. And now it doesn't like expected I32 found a new option. Unwrap. That checks. And it comes up with the same numbers. Okay. And then I think we can do the same thing for cost. Right? We can just loop over all the crabs. Iter. And I was just thinking about this here, hpos. If hpos is equal to pos, then this is going to be 0. So this multiplication ends up being 0. So we can just do it anyway. And we can use a fold on the sum of hpos and num, right? Yeah, that's an improvement. Yeah, we got it down to one line, right? That's pretty good improvement. Thanks, Epic. Yeah, so then we're just summing over this. It's sum plus the cost. No, we are in cost, so it's just num times the callback. R32 abs pos minus. Probably have to star the hpos. We'll find out. Russ will tell us. And then we're just going to sum that. Oh, I keep doing that. I did that earlier. Okay. So that got down to one line. And it comes with the same answer. All right. So we're down to 28 lines out of the original 46, I think it was, that we had yesterday. And there's probably a way to put this cost function inside the map here, but that would make, I think, would make it harder to read. And there's probably a way to do something with this, right? Can we? Because we're doing another loop. What if we loop over our subs iter, and map that for each sub? We can do crabs entry default and then return X. Right? And the reason I want to return X is because I'm trying to find the largest. Does that work? So it doesn't have to be mutable then. And we can just set it equal to this thing. No, it doesn't like that. Oh, it doesn't like it because it's just found a reference, and we need to put a star in there. And now largest is not, it found an option. Unwrap. Expected I32, found I32. Oh boy. Does this really work? It really does work. Okay. This is why I like Rust. So we're down to how many lines? 22 lines. We cut this thing in less than half. So day 7 is pretty easy once you wrap your brain around it. Day 8 was a little more of a challenge. I want to look at my day 8 code again. I'm not going to work on it now, but yeah, this is a beast. No doubt about it. This is a beast. Okay. Is one long line better than two shorter lines? You mean for here? One of the ways. Actually, let me see. Let me do a cargo format on this. Let's do the whole Clippy thing, just to make sure it doesn't mind. Oh, changes to crabs. Okay. And let's see what cargo format did. Yeah. See, so cargo formats spread this out. And then which line was it complaining about? Line 27. We don't need the ampersand there. Okay. Yeah. So to answer your question, yeah. So cargo format will split this all out, and this also got spread out. So formatting it brought it up to 34 lines. It also split this, right? So you can see what it's doing. It's iterating over the crabs and folding. I'm not too much of a fan of this, because if it's just a variable and you do that, I think that might be better, but that's, you know, a matter of opinion. This could have been one line, but that's okay. Yeah, so what this is doing is it's iterating over all the subs, the crab subs. It's mapping that to allow us to insert it into the hash map and return it looking for the maximum value, and that gives us our largest. Sam says you have to name it 4 or less characters. Oh, so if I just called it crab, then it would just go right up. All right. Maybe if I call these subs, because these are really subs. Oh, but I don't want to do that, because then that would confuse us with here. Okay, I'll just leave it. Oops. I hit Control G and it deleted everything. Already it oldest changed. Quit. Git diff. Cargo run. Just double check here. I didn't break it. Okay, everything's working. Git status, git add source, git commit. Day 7 cleanup. And that was a pretty good cleanup, if you ask me. All right, so it is just about the time that I wrap streams up. So I am going to wrap it up now that I went through those things, and we'll have to, I think the waveform collapse stuff for the roguelike is, I think we're almost done with this. We're just adding a few extra builders and doing the map thing there. And then apparently there's some dead code warnings, although I haven't seen that yet. Maybe we're going to get to those. But for now, I'm going to call it a stream. Let's take a look at the overall stats, I guess, and take a look at my personal stats. What did we do? 7:15 to 8. Yeah, it took me an hour just to get part 2. My previous long one was a half hour to get part 2 of day 3. So that was fun. But my rank is pretty good. I cracked the 20,000s. And on private leaderboards, how am I doing here? Oh, I'm up to 5 on that one. Chael shows me at 11. Okay. This one's toggle bit. I'm right here at 9. 199 points. Dang it. And then on Prime, how far down am I? I'm 33. Okay. Those are good. All right. And in 15 and a half hours, we will be at day 9, although I will not be awake for it. Thank you, everybody, for watching my stream and hanging out with me. I appreciate it. I loved all the feedback and all the help. And it looks like Rafael Luba is streaming again this morning. So why don't we go and raid him? All right, I'm going to pause my music and switch to my off screen. Thanks again, everybody, and take care.